Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 2nd, 2025, so just yesterday. It introduces an image morphing method that's an incredible 10 to 50 times faster than older techniques. The paper is titled FreeMorph, Tuning Free Generalized Image Morphing with Diffusion Model. And as we'll see, the results are genuinely impressive. This paper details a new tuning-free approach, which means it avoids the slow, per-instance training that made older methods so impractical. Also, the authors shared their implementation on GitHub, and it looks pretty complete. You'll find the source code, of course, but also clear instructions for getting it running. It covers everything from installation to preparing your own image pairs and generating the morphs. They've included some great examples, too. Alright, and this first figure really shows what the method can do. We see several rows of images. Each one starts with a source picture and ends with a target, showing the generated transition in between. The variety is amazing. A man with balloons morphs into a compass, the pentagon into a diagram. This is done using a framework called the Denoising Diffusion Implicit Model, or DDIM, which is a way to generate images quickly. The authors modify its self-attention modules, the parts that weigh the importance of different image features, to guide this smooth, high-quality transition, all in under 30 seconds. Okay, so we've seen the impressive visual results, but this table shows how the method stacks up quantitatively. It compares their model, called ours, against others using a few key metrics, where lower scores are better. There's LPIPS sum, which measures how similar images look to a person, FID mean, which checks image quality, and PPL sum, which gauges the smoothness of the transition. Across two different benchmarks, their method consistently achieves the lowest, and therefore best, scores in every category. This really backs up the visual evidence we just saw. And these visual comparisons really drive home what those superior numbers from the table actually look like. This figure lines up their method against competitors like IMPUS and Diffmorpher. Look at the top example, a motorcycle morphing into a scooter. Their transition on the bottom is clean and believable, while the others produce blurry, ghostly images. The row labeled spherical interpolation is an especially interesting failure case. The motorcycle becomes a set of chairs, highlighting how their specific guidance techniques are essential for a successful morph. So how do they actually achieve these great results? This next figure breaks down their core technique, which is called guidance-aware spherical interpolation. This is a clever way of blending the features from both the source and target images to steer the transformation. We see what happens when they use only parts of their method. Using just one component results in distorted or ghostly, washed-out images. It's only when they combine all their innovations, as shown in the bottom row labeled ours, that you get that clean, coherent transition. This really highlights how each part of their design is critical. So, to wrap things up, FreeMorph really represents a major step forward. By avoiding the slow, per-image training of older methods, it makes high-quality morphing practical. The key is how it modifies the self-attention modules, using both that guidance-aware spherical interpolation we discussed, and a new technique called the step-oriented variation trend, which smoothly shifts the model's focus from the source to the target image. The result is a method that's up to 50 times faster and sets a new state of the art. That's all for this edition of the AI Research Roundup. Thanks for listening, and I'll see you next time.